Go.
Okay, so my name is Frank Blau. I work for INET Logistics in Dornbirn, Austria, and I'm going to explain blockchain to you in 5 minutes. When you were younger and you went to the bank, you went to a savings bank, they gave you a little book, your little passbook. And in this passbook was every transaction that you ever did with the bank, every input, every output, and it always had the balance, and you could trust that book, right? You could trust this book that it was actually, when it said you had, $9 from your paper route in there, you had $9 from your paper route in it. You could trust that. Well, imagine that all three of us sitting here, there actually are three of us, not just me, we all had a magic book. The word in German is Sparbuch, that's what I'm used to, but it's your passbook basically. If we all had a passbook that magically matched each other, right? Every transaction that one of us did was sent around to everybody else almost in real time. Okay? So it's a ledger, but it's a shared ledger. We all have a copy of it, and it's technologically enforced that they're identical. Okay? That is at the heart of what blockchain is. So blockchain is a shared ledger, and it's cryptographically controlled, and there's all these other things around it. But the idea is that when you do a transaction, it can never change. The order of them can never change because we all share an identical copy. And if one of them is different, all of a sudden that is no longer a legitimate passbook anymore because it doesn't match the other ones, right? So the way that there's two major types of blockchains. There's public and private blockchain, and there's some hybrids of the two and all sorts of weird things coming up that I can't even keep track of anymore. So the public blockchain is what cryptocurrencies like Bitcoin and stuff like that run on, right? So if you, for example, participate in the Bitcoin network, you actually have a copy on your computer, as I do, of every single Bitcoin transaction that ever happened. And it's compressed, it's not like a huge file, it's like 20 gigabytes or something like that. It's not like a massive terabyte file that you have to carry around with you all the time, right? But the idea is that you have provenance of the transaction, right? So now let's talk about what IBM does with that, right? So you have this transaction layer, right? And now imagine you could actually make some agreements with each other, like an agreement about whether or not we got an immunization, right? Someone like your kid is immunized for school, right? And all you really care about as the parent, for example, is that I have a record of it. I don't really care what doctor it was at. I don't really care. I care about a record of it. So you could create a blockchain transaction, again, that we would all have a copy of for that immunization. And then the school could come along when your kid starts school, like in kindergarten or first grade. They could just ask a question of the blockchain, is this kid properly immunized? And they would get back an answer that says yes or no, without ever having to know where, without having to know when, or anything. It's proper because you're enforcing your contracts with technology. And that's what they call these things smart contracts. And what IBM does is they have this whole data layer on top of it. So if you have a complicated data model of stuff, so now let's not talk about an immunization, let's talk about like a medical record that has a lot more data associated with it, right? You wouldn't want to do that on the blockchain because it's not meant to store that much data. So what Hyperledger Fabric, which is IBM's product, does is it has a data layer and has a transaction layer. And those two things can interoperate with each other, and they can communicate with each other through programming languages and stuff like that. So that is blockchain in 5 minutes.
Wow. Yay!